So I'll be speaking. I have given this title. Actually, I have been giving this title because I want to keep it general. So I call it Retracing Saraswati because as of now there are many opinions about Saraswati. I mean, where did the river exist and how did it flow from where to where? So therefore, for me, it is like retracing the path of a river system which probably did exist at some point of time, and there are many controversies. I will touch upon them, but I will confine myself or my whatever I am going to discuss today to the work which we have done, which I have done with my students and my collaborators in PRL, and in recently also we did some work. So those things I will share, and I'll basically convince you that there is something interesting to work on, and probably we can resolve this. Okay, so having said that, I'll start with my talk. So, what is the origin of this problem? So, it is for me, it's a geological problem, but it is actually, if you look at it, this is an archaeological problem because River Saraswati is embedded in the Indian culture, and it is there everywhere, and we worship a goddess in name of the river, which is Saraswati, and it is there right from the very oldest text of Indian context, or let's say Vedas. From there onwards until now, we are still talking about Saraswati. The first time Saraswati or the river Saraswati was looked for, whether such river did exist or not, it happened almost 140 years ago when people actually, particularly the British archaeologists, started to look for a river which they found mentions in Rig Veda. So that is where it started. So the scientific issues related to the river originated somewhere during British period. But before that, people believed probably there are many versions of Saraswati. It is so venerated that every other river in every state will find a Saraswati in every state almost, and many of them are in mostly North India. So let us see what is this problem and why should we bother about it, and what is the importance of this issue. Okay, so little bit of history. It is a venerated river in the Vedas. In almost three or four Vedas, the name of this river is mentioned. It is mentioned, and its geographical location, in a way, is mentioned. And it is also mentioned that it flowed from a slow Himalayas to the ocean. That means it was a perennial river like Ganga, Yamuna, or Satluj. So, in the Rig Veda itself, there are many mentions of how this river flowed. And obviously, according to those texts, it was a very powerful river and perennial. It flowed round the year. Then subsequent texts, so Vedas are the oldest, and then the Puranas and Ramayana and Mahabharata, you must have heard many stories, but nonetheless, they are the texts which were written by people. So there are indications that this river was drying. So the oldest texts uh, do mention that river is powerful, and then subsequent texts mention that the river is drying. So obviously, so much of text cannot be talking about a particular river system unless it really did exist. So the controversies today is mostly on its uncertain age. That means when did it exist, and the controversial geographical location. In the sense, people, there are groups of people, or there is a school of thought which believe this river never existed. There was no river like this, and then the other group believes the river did exist, and it existed in the northwest part of India. And but there is a third group of people who believe this river, name of the river probably came from somewhere else, not from this continent, or not from the subcontinent, let's put it that way. So India never had a river called Saraswati, but the name was borrowed from some other place and it has been inserted. This is what they believe. So this controversy still remains, but slowly it is going away because of a lot of scientific work going into uh, this whole thing. And so it became more interesting in a way when people actually found a dried up river channel in the heartland of Harappan civilization or Indus Valley civilization. So this is the Indus Valley civilization which we See, in the Indian part or in Indian subcontinent, not subcontinent, in India, in the geographic context, I will call it Harappan civilization. It is same as Indus Valley civilization. So the thing is that most after independence, when because most of these Indus Valley major sites which were discovered during British period are located in current Pakistan. But later on, after independence, the Prime Minister, then Prime Minister Nehru, asked people to actually find more sites. And then when excavation took place, they found a large number of sites in a place where then there was no river of like Indus. Let's further, no major river existed, but we had a lot of sites located. So that is where the people realize that these guys were sitting along a, or the settlements are located along a river which is dried up. Since it's a dry channel basically. So today we have a river there called Ghaggar, which is a ephemeral river. It only flows during monsoon, and whenever there is some release of water from some dams, you see the flow of river Ghaggar. So the channel, let's say the alluvium is very large. So it is basically a small river sitting in a very large alluvium. So that is where these people started looking at ancient texts to find whether actually there was any river existed before uh, mm, this so-called ephemerality happened, and then they realized could be the river they have read in Rig Veda or elsewhere, and Britishers themselves actually they named that this could be the Saraswati. So that is where more interest started from scientific organization. But the question remained this, because the Harappan culture or the Harappan cities which are located, let's say now we call it Saraswati River, it has no way to know whether these guys or the Harappans called this as Saraswati. However, the Vedic literature has a mention of the river called Saraswati. Now, if you got, we don't know when the Vedas were written, particularly the Rig Veda, when was it written? There is just a belief or some kind of, um, I mean, people astronomical belief is there. I mean, from calculations and other ways, people put a rough date of 1500 BC. Let's say that. But Harappan culture, you can date it. You know the sites, and we know that Harappan's civilization lasted for between 5500 million BC to 1300 BC. So there you go. So the Vedas, if you believe in this number of 1500 CE BCE, then you know that they are after or very close to the end of Harappan culture. The Vedas are written. However, in Vedas, you have mentioned that river is a powerful river. Now we know for sure now that Harappan culture dispersed, or the culture, the civilization ended probably because of the demise of the river. So how is it possible then that the river which finds mention in Rig Veda, which is a powerful river, in actually it is a drying up river, that because the Harappans started moving out of it. So that is where the controversy started began. I mean, then the people say maybe the mentions in Veda is not this river, some other river, etc. Okay, so why should we study that? I mean, what is so interesting? So, which means if we actually establish that this is Saraswati, it is a big deal. Why? The very existence itself and the location and timing, when did it flow, and the size and nature of its flow can actually link the archaeology with the history of Indian culture. So let's say Vedic civilization or lots of Vedas and etc. are our culture. Harappan civilization is a civilization which we know did exist. If you have a link there, if we can establish the link between these two is basically Saraswati River. If we can establish the existence of this river and its the timing of its flow and the size of its flow, if it was a really powerful river, then we might solve the issue of that. I mean, the Indian history of the Indian culture. So that is where the work of geologists come. I'll show you how. Not only that, it actually can tell us about how river systems die because either of climate change or because of tectonics. Because if Saraswati was a mega river system, what happened to it? This might help. Understanding this kind might help us to understand our future of our river systems, which are fed by glaciers or any other monsoonal rivers. So from that angle, we must study this river and its very existence. Okay. So can it be studied just like that? No, because it is so embedded into our culture. It actually requires very understanding of many things. First, very mention of the Sanskrit ancient texts which are written in Sanskrit. One must know what exactly those guys saw and wrote. So therefore, some Sanskritists or people who understand ancient texts would be required. And also we should have some knowledge of Indology, because how in the culture actually migrated because of demise of the river, how different cultures actually flourished along the river. So this is Indology, how the way India evolved. So that kind of knowledge is required. And then of course you have history, geography, archaeology. All these things are there, one must understand, then only we go into geosciences. Now, when you bring geosciences to resolve this issue or to find the river, find the timing of the river, and find the strength of the river, we need these different branches of geosciences. We need remote sensing, we need geomorphology, sedimentology, we need to date the sand to know when actually the river was carrying them, and we do geochemistry, particularly isotope geochemistry, source fingerprint or fingerprint the sources, so that we know where from the material has come. So thereby we can actually talk river from its origin to the end, in the or where did it fall, and then of course it has implication of tectonics. So all these things, branches of geosciences, together with history, geography, archaeology, we have to consider everything in order to resolve this issue. So many of things I have taken from many different kinds of literature, which I will not discuss. I'll just say what we did and how we did it. Okay. So I hope I am audible still, right? Hello?
Yes, you are.
Yes, sir.
Yes, you are.
Yes,
Yeah,
sir.
yeah.
Yes,
Okay.
yes.
Okay.
Yes,
So
yes.
sometimes when you are speaking, sometimes you feel you're speaking to a screen. So, okay. Thank you, sir. So how did it all begin? In PRL where we were working, I'm basically a geochemist. So we have, and I also do isotope chemistry. So I was basically trained in igneous petrology and isotope geosciences. To use isotope principles to understand the evolution of mantle and all that. However, we also do using isotopes as a source fingerprinting. That means different sources have different isotopic compositions. So if the sediments are derived from them, you can, in a basin, if you study sediment isotopic composition, you may be able to delineate their sources. So we call it provenance study. So I was doing provenance study in Precambrian basins, basically Purana basins. So this is when Dr. Naveen Jwal, who was in PRL earlier, so he was working, he's a basically geomorphologist. So he was working in Great Run of Kutch. So if you can see um, the right hand picture, so there you can see the Great Run of Kutch. There is a box I have made. This is where they were working, Western Great Run of Kutch. So they actually were working to see whether there was a mega river system or fan of a mega river system if it is there. So what they were looking at, there is a river which is called Nara. Uh, I'll put a pointer. So if you see here on the right side, there is a small river today, which is called Nara. Currently, it is connected to Indus through a canal system. Nonetheless, the old sediments of this Nara river is deposited in the Great Run of Kutch. So they are working in these sediments, and they made trenches to find whether in ancient times this river system had anything to do with any of the river system that existed on the northwest plains of India. So this was a paper they published in 2012. The finding is what I want you to see. So they say our study did not find evidence for the existence of a major river draining into the Great Run of Kutch. Okay, I'm still not able to get rid of this dialog box here. Anyway,
We,
so
but we can see the whole full screen, so no problem. I think we are not seeing any dialog box.
no, no. For me, I want to show it,
Acha.
but it is troubling me. Anyway, let me. I can manage, I guess. All right. So this is what they said. They did not find evidence of existence of major river system. So what he did, he gave me some samples which they had collected, and their chronology was established. And they said, okay, you can try to figure out the provenance of these sediments. So this is where they collected ancient sand and silt from this so-called delta region of the Nara River, and then so I was that is where the starting point is. So we said, okay, let us see whether we can find, because here the only thing that you are expecting is probably Indus, because Indus is a powerful river. It is sitting next to it. So any sediment carried by this small river would have heavy influence of the Indus. So if you get anything other than Indus, then there you have either a local source is involved or sources, or there is something which is coming from somewhere else. So that might be able to establish the existence of an ancient river parallel to Indus. This was their hypothesis, but according to their geomorphological study, they did not find anything. So later on, Dr. Professor Rajamani from JNU, you all might know him. So they had published a paper back in 2004, and they actually worked on the Northwest India and the river Ghaggar itself. So they did geochemistry on the modern sand, which is there. So not ancient sand, which uh, now people are working on. So they worked on the modern sand and tried to see if they have any signature, same provenance study, any signature of higher Himalayas that would make the river around the year flowing river. Because if you have a connection to the glaciers, so you'll have a river getting water around the year during non-monsoon period. So thereby it will make the river perennial. So they were looking to connect this Ghaggar with Saraswati, and they of course concluded, because they did not find any evidence, geochemical evidence that will link the modern sand of Ghaggar to higher Himalayas or even lesser Himalayas. So they concluded that probably Ghaggar has nothing to do with this river Saraswati. So then when I read through all the literature, what bothered me is this, that so many workers, particularly the foreign workers, are involved, and they are all are trying to prove no river existed in the northwest India called Saraswati, or no mega river system existed along the Harappan cultural sites. So what worried me, that why people are trying to establish non-existence of a river, which actually, if it didn't really exist, why bother? So that means there may be something which probably relates to some mega river system, which I'll come to why it comes like that. And so they were trying to say, no, this is not this river, some other river probably. So the thing is that this Ghaggar river today, if you see, it is a very petty channel. In fact, they call themselves, people who live there, they call it a nala. It is a very low water content. Only during some floods and all you get a good amount of water. So the river is kind of controlled by the local population. They have dammed everywhere so that the original river is no longer visible anywhere. However, if you look at the floodplain of this so small river, it's huge. So it is very difficult to believe that this small river could have created such a huge floodplain, and particularly in ancient times. So that is where the problem is. So that is why most people wanted to establish or see the link between this northwestern Indian ephemeral river called Ghaggar and the so-called ancient Paleo Ghaggar or Saraswati. So as you can see, most of the worker said that this Saraswati could, there is no Saraswati, or if it was, there was a big river system, it existed much earlier. I'll come to that again. So this is how I started my journey. So, so basically, they were trying to link an extinct river with the Harappan civilization. This is what most of the study did. So then I got, so I read more. So I then got this book, beautiful book. Actually, Rajamani suggested to read this book. Then I also met Michel Denino. So this is a very beautiful book. If you want everything done until 2010, you have all summary in this. So the Lost River on the Trail of Saraswati. Denino, Michel has written a beautiful description of all the texts available until 2010 and summarize it nicely. What exactly is the problem and how we should go about solving this. So this is how I got into or got to know a lot about the old work of British archaeologists and even other things before that. And then I happened to review a book by Professor Valdia. So it was published in 2017. However, 2 years before that, he sent me the manuscript. He wanted some independent opinion, who people who did not have any knowledge of Saraswati. So he sent me through Kanchan Pandey, and I reviewed it. And then I got to know the other aspects of the river, and then I realized that there are two angles to this river system. A lot of people in this country had a belief that this is how it would have happened, but they did not provide any scientific evidence for this. And there is another angle to this. Most people believed there is no river like this. It's just a mythological thing, and therefore it should not, one should not waste time on it. So there are two angles to it. Nonetheless, because there is mentions of a river, because there are more than 700 sites located along the so-called Saraswati. So there is a possibility that this so-called river did exist at this point. Otherwise, how did these people survive? All right. So let us see what we know already about this. So the geography of the Saraswati River becomes important because many people still believe that it is a mythology. Now, if you go back to the actual mention of Saraswati in Rig Veda, the 10.75 hymn, it is called Nadi Stuti Sukta. I'm not good in Sanskrit. Nonetheless, I will read the English part of it. What does it mention? It is basically a prayer for the rivers of India. At that point of time, whatever they saw, they probably lived in northwest India or North India, and they wrote this: "O Ganga, Yamuna, Saraswati, Satudri, Parasuni, follow my praise," etc. So if you look at the names, start with Ganga, go westward. Okay, so this stanza or this hymn actually starts from Ganga. It goes westward, Ganga, Yamuna. Then it goes to Saraswati, then Satlej, then Ira. I have written Parshuni is the older name of Ravi, and then as Chenab, Jalam, etc. So it is basically they are describing rivers. Many of them, or most of them, exist today except for one, which is Saraswati, the red one, as you can see. So what does it mean? So that if it was a mythology, then Ganga should also be a mythological river, Yamuna should also be a mythological river, so also other rivers, but they are not. They are actual rivers flowing today. So therefore, it is very, I mean, these people are smart people who wrote such beautiful texts cannot be so stupid geographically. They can describe a river which did not exist. So obviously there is something wrong with people who believe it's a mythology. So obviously these guys described a river which was called Saraswati and it was flowing like Ganga Yamuna. So it was basically located, if you go by the geographic description, it was located between Yamuna and Satluj. If you believe the way they have described from west to east to west, to start from Ganga going westward, then after Yamuna only they describe this river or mention this river Saraswati and then go on to describe other rivers of western India or Pakistan or Greater India, you can say. So that is the geography. So geography comes from the very old text or the very first mention of this river, and it is mentioned to be existing between or existed between Yamuna and Satluj. Then later texts, of course, the Rig Veda also mentioned that it is one of the seven sisters, that means seven rivers, and it also mentions that this river had a mountainous origin, unbroken, and flowed to the sea. So there are several standards actually. I have summarized them. So they observed that the river is a powerful river because it went all the way to the sea and it flowed from the mountainous origin. I mean, like Ganga Yamuna, it probably flowed from a higher mountains and unbroken. That means it didn't break like small rivers or ephemeral rivers. It had a continuous flow. This is what is mentioned in Rig Veda. Then subsequent texts, particularly Yajurveda, also mentions the same river, which is believed to have written much later. So there they mention about this river and how big it is, etc. However, the texts which were written much after that, the Brahmanas and the Mahabharata, Ramayana, etc., they also mention this river. However, they start describing that the river is actually getting disappearing into the third desert and it is breaking down. That means the river actually, when these texts were written, Brahmanas or Mahabharatas, this river, the so-called Saraswati river or bigger river, is actually slowly disappearing. And it is breaking down and it disappears into the Thar desert. This is what you find mentions. If you know the stories, I am not going to discuss that in Mahabharata and all. There is very well mentioned that the river is actually breaking down and becoming small lakes, etc., and they become continuous during monsoon time. So here we have these are texts which are defining stories, etc., and many other things, religious things. Nonetheless, what you have is the geographical existence of river systems which are still existing today, and they specifically describe a particular river which they worshipped a lot, like Ganga, probably, and they have gone on to describe how in different texts, subsequent texts, how this river is dying. So I took cue from this, and many people also that we should actually, in fact, British archaeologists took this first text itself that Saraswati must therefore exist or would have existed between Yamuna and Satluj. So the exploration of a river system started from there. That means you should look for a river between these two. So, if you know, a question will come afterwards that many people believe there is a Saraswati in Allahabad, and some papers have also come. The thing is that Saraswati is probably a mythology. I'll tell you why it has come. Probably, I mean, according to my belief, and somebody others also believe that. But in original ancient texts, there is no mention of a river Saraswati at Allahabad. Let us put it that way. Okay. So now where are we looking? We are looking here in the Western India. We are looking, if you see, this is the Ghaggar river. Akra is actually a river which doesn't exist anymore. It only is at times when you have enough water in Ghaggar, it does flow. And Nara is the river that connects further down and falls in Great Run of Kutch. So if you go by the geography between Satluj and Yamuna, there was this river. If you think this river is occupying present day Ghaggar, Akra, are occupying an ancient river systems chain, then your river, the Saraswati river, should have existed something like this. That means it would have originated from somewhere here and went all the way to Great Run of Kutch, where of course it meets the Arabian Sea. Now, there are a whole host of workers, archaeologists, Indologists, there are historians who have worked, including Archaeological Survey of India. They all believe that this is Saraswati. Not only that, I think ASI has also gone on to describe the Harappan sites which occur along the Ghaggar plains today as Saraswati civilization. So if you look at, this is a picture taken from Danino's book. So these are the small dots you see. They are the Harappan sites discovered after independence. There are so many of them. I think I read in Poshel's book, there are close to 400 or 500 of them, or maybe more. So they were discovered all along the so-called river system, or today we call it Ghaggar. So these guys were sitting along a river which if you believe in the work, which a lot of work which has been done, that if it is not Saraswati or it is not a perennial river, not powerful river, so those civilization try are sustained by an ephemeral river called Ghaggar. This is the belief which many people have. Nonetheless, the This is the fact that these sites are located along a dried off channel of an ancient river. Okay. So this is Ghaggar. On the upper part, it is called Ghaggar in Indian side, and then there is the middle part which is called Hakra, and the finally it is called Nara. So if you connect all these three, then there would be a single river that will start from Himalayas and go all the way to Great Run of Kutch, or today's Great Run of Kutch, particularly the western Great Run of Kutch. This is what could have been the river, but we'll see whether it is or not. So, so what is the connection? I discussed this, but I'll like to emphasize more on it. The Saraswati. So now we believe this Hakra, Ghaggar, Hakra, Nara probably was a river, mega river, and it was probably called Saraswati. So where along these banks, these Harappans actually made their settlements. Now, if you look at, so this is the settlement dynamics made in a paper by Geoscientists et al. In 2012. So these are the red dots are the sites of Harappan sites. So if you look at it, what a very interesting thing you'll find this Indus Valley civilization or Harappan civilization. The early phase started, early phase was between 5500 to 2600 BC. The mature phase was between 2600 to 1900. Late phase was 19 to 1300. If you look at the early and mature phase, you will see, even though we call it Indus Valley Civilization because it was first discovered in along Indus, most of the sites, a large number of the sites, are actually located not along Indus. Okay, so they are located along the so-called ephemeral river, or people believe not a river. So you see, so many sites. This is actual finding. This is how they actually made their settlements. In fact, some of them are between Ganga, sorry, Yamuna and Satluj, and most of them are all along this so-called river channel, which we think could be Saraswati. However, when you go to the late phase, you'll see there is a dispersal. So the settlements you see they have dispersed either towards west or most of them towards east. That means they started occupying Yamuna and Ganga plains. So what are the findings in this paper and the papers before that? That what they say that probably these guys actually settled down along a monsoon-fed river. So they still believe that this river, even though it was called the Saraswati, it would have probably a monsoon-fed river, and these Harappan sites were located along that. And so the conclusion was, since in Rig Veda it is mentioned Saraswati was a powerful river, this came into conflict. So therefore, these people, Gyosa, that group and other group, Peter Cliff's group, they said the early Vedic age is older than the mature Harappan period. Because if Vedas mention a river which is powerful, and we find settlements along a river which is ephemeral, that means these Vedic people were probably mentioning a river which is much older than this. So that becomes controversial because we believe Vedas were written probably towards the mature or late phase of the Harappan civilization. So that means they saw the river flowing, powerful river flowing, but geological evidence, the way these people have presented, suggests that the river was ephemeral. So then there is a problem here. This is not a monsoon-fed river. That is what Vedic people believe. But in actual, it looks like a monsoon-fed river. So that therefore it became controversial. So if you see the implication is that the existence of the river itself became controversial. So there is a little bit of remote sensing I have to bring in. If you see, there will be hundreds of paleo channels. So, in fact, at some point, ISRO people and people whom I know very closely, they argued that of course, the same river is this, but based on remote sensing data. However, one must understand remote sensing can give you paleo channels. They will also give you because it is based on water content or aquifer. They basically you can only map aquifers based on the moisture content. So you can see if this is the Ghaggar Hakra channels, you can see I have written down all the papers here. This is actually whole thing taken. So you can see many paleo channels that go all along this, and one of them is of course Ghaggar Hakra system. So some people suggested they dated water. Actually, BRC dated carbon 14 dating of waters collected from these aquifers. So they went underground, collected underground samples from wells, etc., and dated, and they found ages to be like this, from 12,400 to 1300 for 40 years before present. And they argued that the Saraswati water is, therefore, this is Saraswati because this water is very old. Now, the problem is, you geologists would know very easily, hydrologists will know better than us, that in an aquifer system, and these are alluvial aquifers, so they are unconfined aquifers. You can recharge them every year. So these dates have no meaning because you get a mixing line between the oldest water and the youngest water. Whenever the recharge happens, that water will go and alter the age of the old water. So the problem with paleo channel line of argument is this: these are, you don't know whether it's a paleo channel or some other aquifer, and these are unconfined aquifers. So therefore, the edges you get are mixed edges. So it cannot tell you why I'm saying about this, because the age becomes important, because when the river was flowing is important to know whether it was during the Harappan period or before that or after that. That will probably resolve the issue. That's why they dated this and suggested that this
Yes,
matches with the.
मैं थोड़ा
Hello?
टेस्ट करा दे खोल के.
Oh, sorry. So therefore, what I am trying to suggest is that aquifer mapping or through remote sensing, it will not be possible to resolve what we are trying to address. So now I formulate the questions. So before you go, you should have a very clear questions in your mind. Then only you can resolve some outstanding issues. The first question I asked: did the river Gaggar has a perennial past? So today we know in northwest India there is a river which is monsoon fed, it's Gaggar, whether it was perennial or not in the past, particularly during Holocene when Harappan civilization was existing there. In other words, was the river glacier fed? If you have a base flow maintained all the time, that means in Indo-Gangetic plain you need a connection to glaciers like Ganga and Yamuna, so that in summer seasons also you get water. Of course, there will be base flow because of groundwater going into this. However, whether Ghaggar was at any point of time, particularly during Holocene, connected to higher Himalayas, which had glaciers. Second would be, did the Ghaggar flow down to the Great Run of Kutch? Now, if you describe a powerful river and you say that it's from the mountain to the sea, then you have to say, see or find out where actually it goes and meets the sea. And in other words, was there a connection between Ghaggar, Hakra, and Nara and going into the Great Run of Kutch? That needs to be established. And last, which is most important, did the Harappans build their settlements along a perennial Ghaggar? So if Harappan, because the argument is that Harappans probably lived along an ephemeral river. Now we want to establish the Ghaggar was perennial at that point of time when these guys settled down there. So these kind of questions can only be answered by geological investigation, not by archaeology or any other kind of investigation. So therefore, geologists must go into such kind of problems where existence of rivers or their flow, their history are concerned. All right. So how do we approach this problem? So obviously, I made the questions clear. Timing is important. So we have to find age of deposition of the ancient sediments. That means the sediments this river carried in the past must be dated, so that we know at what time frame we are talking about and what sediment we are talking about. And of course, we need to know the nature of sediment deposited, because as you know, the sediment can vary depending on the strength of the river, so which could have varied with time. And if it was a powerful river coming from, let's say, higher Himalayas, it will probably deposit sand. If it is a monsoonal flood, if it is recycling older sediments, you will expect silt, clay, etc. Or if it is a dried up channel, only occasional flow is there, you will expect sand dunes coming into the river, which happens now in Gaggar Plains. So basically, if you study the sediment, nature of sediments which are deposited, let's say during last 10, 20,000 years, then you will know the strength of the river in the past. And last, which is what we are expert is are we want to understand the source and depositional pathway. So we use various tracers or provenance tracers to actually find out the source of this material, and of course that will reveal you the pathways of deposition. So you get the sediments, date them, and then find out their provenances. That would likely to answer all our three questions. So this I don't want to discuss in detail how it is done, just to give you some idea because there are students how this provenance study is done. First, of course, in a river valley, this is something I learned because I was all my life, I was sampling igneous rocks or sedimentary rocks. You have to break rocks. Here you have to make trenches or take course to go down in the past. And so along the river or on the either side of the river or in the floodplains, you have to make trenches like this. Or if you are lucky, like we were at times, where the trenches were already made by sections are available because of various reasons or mining and all that. So you get trenches or you make your own trench and sample sediments to time, and or you do coring if you are rich, or if you have access, you can do many cores. It will get a higher resolution and a longer time duration. So how this provenance study works, the way we do it. So I have given one example here. So if you look at, let's say this is our catchment, okay, from where the sand is derived. So this is our sample, this is our source. Now the source, this is a very simplistic view I have given here. The source I have given here, there are four sources here, or let's say four domains of four rocks, let's say. So what we have, there are many things you can take, but here I have taken four very distinct source indicating parameters. One is in Himalayas, you have these micas, particularly muscovite, whose edges you get these in higher Himalayas, you have these crystallines, which form many of these granites formed around 20 million years ago. So the micas in there are white mica are 20 million years. Then let's say you have zircons which are very old, 750, because I'm talking about a domain or a lithotectonic unit. So there are four of them with a strontium, neodymium isotope composition which are different. So if it is derived, the fluvial sand is derived from here, which is you are looking at some other place. So if you see here I have written, so you measure the composition. If you get the mica, you date them. This will give you the age of the mica. Then you date the zircons by detrital zircon uranium lead geochronology, and you can find out the isotopic composition epsilon neodymium or strontium. Oof, this is bothering me really.
On the right top, you have three dots. There you can stop erroneous. Maybe that will help.
Do what?
On the right top, you
Yeah, I
have
see
three dots.
dots. Then
So if you click that, there may be something called stop annotation from others or something like that.
no. I'm worried about this. This panel is showing me and troubling me. Whenever
The
I move
lower,
my, huh?
the lower one or the upper side?
Yes, yeah, lower one.
That you can.
You
if
move your mouse pointer upward.
Not this one. Your things is with the zoom, right?
See, I have done full screen, but my text below is covered with this panel. This is what.
Yeah, your mouse pointer, your mouse pointer should be moved upward. If he stays within that, then the lower
No, it
panel
is
will come.
constantly visible. That's what I'm saying.
Okay.
ठीक है, I'll try. Okay, so So let's say this sand is derived from these sources. So we want to know which source have contributed to this sand. So first we can date the sand. So if you are lucky, you may find fossils, or you can find shales which lived along or within the river system during the sand deposition. So you can date them by carbon 14, or you can actually also date by luminescence dating of OSL or TL, whatever. So you know the timing of deposition of the sand. And then these things is what you measure in the sand. So you find micas, date them, you find zircons, date them, and then of course strontium and neodymium isotopic compositions. Now from here you have to find where from it has come. So if you look at it, the mica, 20 million year mica is available only in this source. So very clearly that means this has contributed. And if you look at the isotopic composition, or if you look at zircon, it shows a population between 550 and 700. So obviously there is younger zircons which are available in this source. And you can also see the isotopic compositions which are between this and this. So that means we can find out that, or we can say confidently that these two lithotectonic units would have contributed sediments to the deposited in your river system or wherever. This is a very simplistic view because no source is a single source. There are multiple sources, and when river flows down, you have many tributaries joining into it. So the source compositions vary. Nonetheless, one has to make a smart estimation of where from it would have come. So I'll tell you how one can do, and there are certain distinct signatures which you can very easily find out. For example, these micas are very unique. You can see in Ganga sediments, in Yamuna sediments, Satluj, this thing, but you will not see them. 20 million year mica will not be there in, let's say, Chambal sediments or any other continental cratonic river system. So there are very distinct provenance indicators which can be utilized to find out the source of the sediments. And of course, you can date the sediment if you are looking in the range or wherever using carbon 14 or OSL to find the age of deposition. So what I just told you. So the material and samples what we have used is the sediment and minerals using core, dog whales, etc. Shells of mollusks, basically the pelecypods or whatever gastropods which live along the banks or within the water, which can be dated by carbon 14 because they have a small lifetime. So they will die and get deposited within the sediment. So you know the age of the deposition by dating them. Or you can, if you are lucky, you can get other archaeological evidence also buried inside it. If you can date charcoals, etc., that also will give you age of the deposition, like potteries or bricks. They can also tell you the depositional age of the sediment we are looking at. And methods, of course, a lot of extensive field is required to understand the stratigraphy and sedimentology, particularly grain size variation, etc. And then these three things I have marked in red is not our expertise. We are not doing it. Clay mineralogy we have done a little bit, not much. Remote sensing is not our expertise. Zircon geochronology we are starting. We'll hopefully will be able to detrital zircons also can be done. But in this work, whatever we use were from other studies. And last four is what we did it. Detrital muscovite dating was done in collaboration with Dr. Kanchan Pandey from IIT Bombay, and other things were done in PRL. So I was, let me put it what earlier studies have done using the similar kind of technology. When we started in 2014 or so, so this is what was known. So these are some references I have given here, but there are many. So whether it was flowing all the way to as an independent river flowing all the way to Great Run of Kutch, and whether it was connected to higher Himalayas and carrying uh, sediments in it. So that would establish the perenniality of the river. And of course, the timing of sediments will tell you when this river was existing. So what others have found is what I'm trying to say. So some people have found that Yamuna was once upon a time connected to Ghaggar. So if it was connected, it would have been a very powerful river. The timing remains controversial. We will see how. And then, of course, there is a view and that Satluj was connected to Ghaggar, but when, that also needs to be established. And then, of course, Hakra and Nara. This continuity needs to be established. As of now, because most part of the river is in Pakistan or buried in Thar Desert, we have no access to it. If it were really continuous, you should get the similar kind of sediment all along it or below the surface. That needs to be established. And there are theories that it's not showing up. That Satluj might have connected to this river at a different point than what on the upstreams we saw. All these studies which I have listed here, one thing they say based on their ages is the following, that they agree that this river system where you are looking at a paleo channel was indeed a perennial river. That means it was a mega river system. However, they believe that it was existing much before the Harappan civilization. So you have to imagine this way, the way they have put it, that if Yamuna was contributing, if Satluj was contributing, these two are very large rivers. By default, this Ghaggar system would have been a very large river system in the past. But when the ages that they have given, they say that it probably was so in much before, at least the youngest age they have is 14 kilo year. Some ages are there of 8 kilo year by Ajit Singh et al. Nonetheless, most of the ages are probably before 20 kilo year. So that means Harappans, when they lived, this river was actually not in existence. This is what most people argue who believe in this theory, that indeed this river was a large river system. However, when Harappan settled down here, this river did not exist at this point, which becomes very interesting. Let us see. So I was very lucky. I had a student, Anirban. I hope he is listening today. So he decided, I mean, I asked him whether he would like to work in. He was very interested and he was very smart to give many, many different ideas. So with him, we started this work. So we started from the very first thing to see if this river indeed actually flowed all the way down, then we should see some signature in the past in the Great Run of Kutch. So that means we wanted to establish that the Ghaggar, Hakra, Nara, this Ghaggar, Hakra, Nara should have been connected, and when it was connected, and whether we have any sediments that could link this river to higher Himalayas. This was what the first step we started. The first paper we actually published in 2017. So this is a Great Run of Kutch. Pictorially, this is the so-called delta of Nara River actually. I mean, I'm not sure. Some people have suggested this to be a delta, but it remains to be actually really understood whether it's a delta system or not. Nonetheless, our samples come from here, so you can these sections. So this is courtesy Dr. Naveen Jwal. So they were already dated. So what we did provenance study. So the ages when goes back to 5,500 kilo years, 5,500 years. So you looked at sediments as old as 5,500. So it has all sand, silt, and silty clay, etc. So what we did all isotopic characterization, epsilon, neodymium, strontium, and also geochemistry. I will not bore you with all these details. So basically, we tried to establish provenance of each type of sediment we sampled from 5,500 years to probably 1,000 years before present. One thing is very clear. If you see what we do, basically, these are the fields of different lithotectonic units or different sediment sources. So this is Indus Cell, for example. This is Indus Delta. That's Ganga, Yamuna, Satluj. This is Ghaggar. So our sediments fall here. So which is kind of intuitive because we are looking at the sediment basin very close to Indus River, which is a very powerful river. So it is expected that most of the sediment would be coming from Indus system. Nonetheless, there was small fraction which we think could have come from Ghaggar. But one thing was for sure, we did not see any higher Himalayan river that would have drained into Great Run of Kutch uh, since 5,000 year, 5,000 years. That means between 5,000 years and today, or 1,000 years, there was no big river. So if it was there, it would have been before that. And the source of the sediments were Indus, as I told you. However, we did find 20 to 30% of sediments which came from Ghaggar system. That means modern Ghaggar, if you analyze modern Ghaggar, the kind of composition we get, the same type of composition comes here. That means it is not entirely Indus. There is a 20 to 30% sediment which could have been contributed by Ghaggar. This is what we concluded. So it is not a higher Himalayan source or anything, but what does it establish? It actually establishes that Ghaggar could have been connected to Nara. That means this channel was probably open in the very recent past. So this is what we probably established. We think that the second one, this connection is real. That means Ghaggar, Hakka, Nara, these three river systems are actually a single river system. The material from Ghaggar happens to be there in Great Run of Kutch, brought by Nara, deposited somewhere during 5 kilo year to 1 kilo year, which means this connection was there as young as probably 3,000 years ago, right? Sorry, 1 kilo year ago means 2,000 years ago, roughly. So, or 1,000 years ago. So you can imagine. So if this link was existing in the past, this could have been bigger. This is what we thought. Now the next thing would be to actually go to Hakra and find out, which is not accessible. The next best thing was to go to the actual Ghaggar channel and the Harappan cities. So Anirban came up with a beautiful idea. So far we went to this Kalibanga. So Kalibanga, as you know, is a major Harappan site. It is believed to be a mature Harappan site. Of course, it has early phases also. So what is that we did? See, these Harappans use potteries, like any other. You get a lot of potteries, bricks, etc. So these are made of clay. However, to strengthen this material, people use sand. So what kind of sand they would use? Whatever is available to them. So Kalibangan is actually located along Ghaggar, on the banks of the Ghaggar. So obviously, I mean, one would think intuitively that these people would have used the sand which is available to them in the river basin. So, in other words, if you can find the source of the sand used by mature Harappans to make their bricks or to these potteries to strengthen them, if you can find the source of the sand, then you might know what sand existed in the river system. If it was higher Himalayan sand or sand from Shivaliks or sand from the dunes. So with that idea in mind, what we analyzed strontium neodymium. So we had this idea about the sections here, that is from Dr. Saini's work. So along Kalibanga, near Kalibanga or Pilibanga, you have some sections. They are described on sections. This arrow you see, these are mature Harappan time. Okay, so there itself you know that when mature Harappan so here what you see the major lithology here, one is gray sand, okay, which is basically pure fluvial sand you get, and then top of it you get yellow sand, which is probably dune sand or reworked sand, and then on the top you get silty mud, okay, clay rich, so which is basically recycled river and when it is not very powerful. So sand which is micaceous gray sand which is at the bottom, and the edges if you see they have dated some of them. So from here you can see they are quite deep, more than a meter or so. So nonetheless, if this sand was available to them, they would have made use of this sand. However, when we plotted the isotopic composition of the potteries, we realized that they never made use of this so-called sand, which could be higher Himalayan derived because they contain mica and they're white or gray in color, like Satluj or Yamuna sand. What they had used is actually the yellowish brown sand, which is probably reworked dune sand, which means, in other words, this is the sand which was readily available to them, which they used. If you interpret that, it is very clear that mature Harappans did not have access to a large river system or a river that carried these sands, which are higher Himalayan sands. So, here, in an indirect approach, what we found that when when the Harappan civilization matured in Kalibanga, those guys were looking at the river which was recycling its old sediments or recycling, getting the dune sediments which are deposited around it, and not the sand which you would expect in a larger river system. So that means the river had already become weaker or ephemeral by the time the civilization had matured. This is an indirect evidence we got from Kalibanga. So we went further. We said no, one particular station is not good enough. So we covered from Hanumangarh to Anupgarh. So this is the entire stretch of Ghaggar, and then we collected all information from all earlier work. And so this is one example I can show you how it looks when you have real fluvial sand, which is very similar to what you see in Satluj or Ganga or Yamuna. You see this gray sand. So this is a section close to Ghaggar, not along the Ghaggar, because modern river is heavily controlled by humans. So today where it is flowing may not have been the old river. So if you look around on the other side of the present river, you might end up with sections like this. So here we get silty clay and gray sand. So clearly at this point of time, and if you look at the grain size, this is how it looks. This picture, if you look. So this sand cannot be a reworked sand. This is reworked, you can see. And this sand has these mica which are unaltered. They are beautiful micas, very mica you see in modern sediments of Satluj or Ganga or Yamuna, which are higher Himalayan derived. So anyway, so what we did, we established stratigraphy along where many sections we studied, did geochronology. For every section you have to establish geochronology because you need to know when these things were deposited. So we are many places we are lucky to get some shales which could be dated. In other places we dated the sand by OSL, and then we of course we studied the provenance of the sediment. So in two different modes, we studied the provenance. These micas, as I told you, can be dated by argon. So we did that. So that will give us an idea whether they are coming from very old rocks or the young higher Himalayan granites, which are 20 million years. And of course, we did strontium neodymium isotopic composition in this sand or silt, whatever, and tried to find the sources in the Himalayas. So I have combined everything, all earlier work, our work, etc. And Anil Shukla is a faculty in PRL. He did most of our OSL datings. And here I have combined many data. So you can see so many sections we had covered. It has, some of them are ours, some of them from earlier work. And in majority of the sections, if you see, we get basically four types of lithology. One is a gray mica sand, and one is a gray clay, which is very rare you will see. But then you have yellowish brown sand, and last on the top, which is mostly modern, is brown silty clay. So all along Ghaggar floodplain, you do get a sand. Probably most of the cases below 5 to 6 meters from the surface, you get this sand, which is exactly like Satluj sand or Yamuna sand. And then the younger sediments, you will see yellow sand, which looks like reworked dune sand. And then on the top, which is present deposit, deposited in the very recent past by a ephemeral system. And as I told you, we got these shales which were dated to find out the age of deposition, and we used OSL to date. So there are ages here written, but I'll put together and show you a better picture. So just to show the kind of compilation has gone in and to establish what I'm going to say now. So what is that we find from all this exercise? So this is the area which is covered. Okay. So what we see, the distribution of fluvial origin micaceous sand layers along the Ghaggar. So as I showed you, there is a big sand layer which occurs below the surface. Well, most of the time below like 5 or 6 meters below the surface, and this is a typical of sand you get in Satluj or Yamuna. So when you date them, what you find is that most of these sand layers are older than 20 kilo years. So this is what most people had found all along this, and they had reported therefore that the mega rivers, because this sand can only be carried by a river as powerful as Satluj or Yamuna. So therefore they had concluded that the river did exist, a mega river did exist along the Harappan heartland. However, it was older than 20 years. What they did not report, which we are reporting or we have reported, is another layer of the same sand. It's repeated around 9 kilo year to 4.5 kilo year ago. Between 9,000 years before present and 4,005 years before present, the same gray sand started to reappear or occurred between this. In between, you have this yellow sand, and after that, you have this mud, which is a modern river system. So, what it means, there was a rejuvenation. This is what we have interpreted and published, that this gray sand deposition recurring after a gap of almost 10 kilo years is actually reactivation of this river. Now, how did that happen? What implication it has for the civilization? So let us see. So we conclude that the Paleo River, first thing, since up right from 80 kilo year to 20 kilo year, you see this deposition of gray sand. So that establishes one thing, that this river was not ephemeral at all. It was a very powerful river, at least up to 20 kilo year. So 20 kilo year is the last glacial maximum, right? So until then, this river was a powerful river which carried higher Himalayan sand. Okay, and then for some reason, could be climatic or tectonic, it becomes ephemeral or monsoon fade. It reworks the sediments, or it becomes yellow, or the dunes actually come into the river, or it recycles dunes and etc. But then again, you see the gray sand reappearing at 9 kilo year and continuing up to 4.5 kilo year. Okay, so we did establish that it was a powerful river, otherwise you will not get this sand. And then what we did, we dated this by argon. So these are argon plateau of the Muscovites. Now I told you they can be provenance indicators, and what we find is beautiful. We found that all of them actually show 20 kilo year peak. So these mica, this is a relative probability of Muscovite ages observed in various lithotectonic units. This is lower Himalaya, this blue one. This red one is higher Himalayan crystallines, and this is Sivalix. So you can see where it falls. It is exactly on the Ghaggar micas or Ghaggar gray sand micas at 20 kilo years, which is the peak of 20 kilo year granitic intrusions in higher Himalayas. That is where most of the micas come in Ganga, Yamuna, and Satluj. So very clearly, we have sand from higher Himalayas deposited as gray sand in the Ghaggar plains. And when we did isotope composition, we clearly, you can see they fall exactly along with samples or sand of Satluj, Yamuna, Ganga. So these are these gray sand. Whereas the other sands, the modern or the dune sands, they fall here. So they have a different origin altogether. They are mostly recycled from Thar Desert. Thar Desert has Indus sand, etc., etc. So what we are focusing on, that when the river was powerful, it was carrying sand very similar to what Satluj carries today, or Ganga carries today, or Yamuna carries today. This is the conclusion here. Okay, so now we compiled everything and tried in the context of settlement dynamics of Harappans. So only for last 20 kilo years, because that is the point of interest. So this is a very busy figure. I don't want you to get into all that. What is on the right panel is the settlement dynamics. That means how these Harappans made their settlements. So if you look at pre-Harappans, there are only few sites. Then early Harappans, You see so many sites. So this is between 5.8 to 4.6 kilometers. So you see these sites all along the so-called Ghaggar. Now we have established this Ghaggar was probably a mega river system. So now I can call it Saraswati because of its geographic location. So all these settlements are along Saraswati. Then when the civilization matured during this period, 4.6 to 3.9, you see that there is a dispersal on, on towards west as well as towards east. And then the post-Harappan or post-urban phase, or you call it post-Harappan period, between 3.9 to 3.5, you see most of them have vanished from the middle. They are all gone towards Yamuna or Ganga. Some of them are still remaining here because there is, I think I showed you earlier, people believe Satluj was connecting here into the Hakra. Anyway, so this is the settlement dynamics. Now, how we want to connect it to what we see in Ghaggar plain. So here you see it's a lithology, lithostratigraphy built along with strontium neodymium isotopic composition. So if you see these gray things, these are the gray sands. And isotopically, if you see, the higher Himalayan sediments contributed to these. So at this point of time, if you look here, this is where this higher Himalayan sediments were coming when the Harappan cities were flourishing. In other words, the early Harappan cities, okay, not the mature, the early Harappan cities were actually existing when the river was carrying higher Himalayan sediments. In other words, when it was perennial. So if I put these things into context, this is what I get. That Harappan had built their initial settlements along a perennial river. It is not that they occupied an ephemeral river, because we have very clear signs. You have higher Himalayan sediments, that means either Satluj, Yamuna, or directly it is connected to higher Himalaya. That means it has perennial water supply. That is when these early Harappan settled here. So very interestingly, as I showed you earlier from pottery work, that mature Harappans, when they matured, they did not see a large river system. That means it was already slowly drying up when they matured. And then that might have led to their dispersal at some point. So the finding is that we do find this river was a perennial river. And at that point of time, when it perenniality was there, this is when the Harappans built their settlements. So what is the history of this river? Up to 20 kilo years, it flows. I don't know when it started, but up to 20 kilo years, it flows like a mega river system. Then it vanishes or becomes very feeble for quite a long time, almost 11 kilo years. Then at 9 kilo year, it gets rejuvenated. And then while it is still active or still perennial, Harappans come and settle here. But by the time the civilization matures, this river dries up again. This is the story. This is from our work. So now the question comes, if it was perennial, was it connected to higher Himalayas? Because we get higher Himalayan sediments. So how did it get it here? So there are two ways it could have got this. Either Ghaggar itself or Saraswati itself was connected to higher Himalaya, or it was being fed by, as I told you earlier, a Yamuna or place. To establish that, you have to go to the Shivaliks and see the tributaries of Saraswati or Ghaggar. So there are two tributaries. One of them is Markanda. In fact, there is a hypothesis that Markanda was connected to Yamuna. So a lot of stories goes in. You can see that. So let me put it in a simple thing. There is a theory supported by Oldham and Valdia that the river Markanda, which is a tributary of Ghaggar, or let's say put it this way, the tributary of Saraswati, was connected to higher Himalaya through one of the channels of Yamuna. In other words, it could be a paleo channel of Yamuna. So if Yamuna was connected up there, or Markanda Saraswati was connected to Yamuna up there, then it would have simply carried higher Himalayan sediments into this. So we wanted to test this hypothesis. So Ajit, who was a postdoc in Gandhinagar, IIT Gandhinagar, working with Vikrant Jain, currently he is in Panchkula. So he did the field work. We collected a lot of samples, and from there we tried to establish whether we have the provenance of higher Himalaya here. So interestingly, there is this tributary is called Bata River. There is a drainage divided between Markanda and Bata. It's hardly a kilometer or so, or 2 kilometers, 1.5 kilometers. So it is quite possible that this was connected. But what we find is otherwise. So here, I mean, I don't want to explain in detail. We find that Markanda samples, whatever we get, dating all the way to 57 kilo years, has no connection to Yamuna and Ganga sources. In other words, higher Himalayan sediments plot here, okay, whereas Markanda plots here, Ghaggar and Markanda modern sediments. So, but these Markanda sediments go back to 57. The oldest we have is 57 kilo year. But at least during the Holocene, none of them came from higher Himalayas. And we went on to explain the mixing trend, etc. But the point is this, that this Ghaggar actually was not connected to the higher Himalaya during the Holocene through this Markanda. So if it was not a direct connection, how did it get that sand? So this was the question that still remains. So what we did, so this is still needs to be established, the timing, etc. But we did a simple experiment that these shells, these bivalves or gastropods, or whatever, when these are made up of calcium carbonate, so they live in those rivers, and the water composition of strontium is reflected in them. In other words, they take the strontium from the water. Whatever composition of the water is there, they will have the same isotopic composition, 87/86. So they can be used as an indicator of the river water composition. So what we did, we measured their isotopic composition, 87/86. So this green color is their isotopic composition. And this was dated from a layer which is 6 kilo year. So at 6 kilo year ago or 6,000 years ago, the gray sand was existing. In that gray sand, we collected these fossils and measured their isotopic composition. So they will tell us the isotopic composition of the water in which they lived. And what was that water then? So if you look at Yamuna water has composition that varies like this. Satluj water has a composition that varies like this. So it overlaps with that. The shale water strontium composition overlaps with the modern Satluj composition. So Satluj water has not changed much. The water composition depends, strontium isotope of water depends on the lithology they are eroding or weathering. So it has not changed much. So you can see there is a clear overlap. In other words, that means Satluj water was probably flowing into Ghaggar. Okay, but what about the older time period? So right now we have not done this work, but earlier people, as I told you, they had suggested at one point Yamuna would have been connected to Ghaggar in the plains, not here. So if that were so, then I can put this line off with a question mark. But this is what we established, that Satluj water would have, based on this, again, the evidence is only one evidence we have. But we have these sediments, so therefore these two rivers must contribute at some point of time. The timing has to be established. But we have an indication that Satluj water was indeed there flowing in this river channel. So the perenniality would have been established if you have a powerful river flowing into Ghaggar, it would have been a perennial river. So in other words, Ghaggar could have been a system of Satluj itself. Between this time period, 9 kilo year to 4.5 kilo year, or 9,000 years to 4,500 years ago, when Harappans actually came and settled down here. So I want to summarize. I'm not sure how much I have convinced you, but with the work, what we have done, this is a summary of all that I have spoken so far. First thing is that we do establish this, and which is also established by others, that Ghaggar was a perennial glacial fed river. There is no doubt about it. I mean, ancient Ghaggar. During 80 to 20 kilo year, this one everybody agrees. However, this is what is our finding, that there was a rejuvenation of the river. There was in between a dry period. We believe this dry period could be because of the glacial event, because LGM is was 20 kilo year. It could be monsoon, anything. I mean, we don't know. We have to one has to establish. Similarly, why did it vanish at 4.5? Disconnection of river Satluj because of tectonics or because of some other reason like climate. 4.5 or 4.3, as you know, is the Meghalayan stage. Does it have anything to do with that climate scenario? We don't know. We have not established it, but this timing is very intriguing. So, in between a dry phase, but it gets rejuvenated between this period and again vanishes. So, this rejuvenation phase is what uh, actually caused the Harappans to build their early settlements. Okay, so this is the period where probably this was called a Saraswati. So we wanted to say this, that this rejuvenated ancient Ghaggar was actually Saraswati, where Harappan civilization built their early settlements. However, when they matured, the river started to vanish. Okay, so this is what I told just now. The connection which we tried to establish, but it is still remains to be seen, is that the Ghaggar River or Saraswati River did flow into the Great Run of Kutch. There is some kind of evidence, but it remains to be really established that this river really fell in Arabian Sea at Great Run of Kutch or in Great Run of Kutch. So some indications are there here and there, some papers are there, but because we don't have access to large part of this river in Pakistan, it is very difficult to establish at this point. But maybe in future it will be resolved. This 4.5 kilo year, as I suggested, it needs to be studied very carefully, because you must have seen some papers have come recently that the demise of the civilization could be linked to Meghalayan stage, which happened around 4.3 kilo years ago. So which may be linked because it was a regional event, if not global. The, the demise of the river Saraswati could be linked to that also. So with this, I'll end my talk, and I thank everybody for listening patiently for so long.